Hey, first I want to apologize for being in the way between hearing more from Phil. So I'll get started so you can listen to him more. So you're probably wondering what I'm doing on stage together with Abhi, since I'm working more in a diagnostic context and he's working on a completely different use case. So we might not seem to have much in common, except that we couldn't agree on who was going to do the talk, so that's why we're both here. But actually, more seriously, we have a few use cases and challenges in common. So we wanted to kind of explain a little bit more in this talk about infrastructure stuff. So I know there's been a lot of talk about Nextflow itself, but ours will be a bit more about where do you actually run your Nextflow infrastructure and how do you run it. So to get started on the different challenges that we came across in our context. First one, since we're in a clinical context, data privacy is very important. And every institution seems to have a little bit of different interpretation on how to handle that. Unfortunately, my hospital has the interpretation that on-prem is the only permissible way to run your workflows, which was a little bit difficult. So we've always been stuck with working with on-prem solutions. Another operational challenge is that we also want to be able to run our workflows like federated, but by mean we have different infrastructure. So we have our diagnostic infrastructure, which is segregated, but we also want to be able to run the same workflows on HPC on different compute options. So we want a little bit of operational flexibility. Operational simplicity is also a very important one. Since we're a government institution, it's very difficult to hire people, especially sysadmin people, to manage servers. So operational simplicity is a very important one. We're a small team. It's only 10 of us, 3 bioinformaticians and 1 half-time sysadmin. So we need to really focus on the bioinformatics and not spend too much time managing servers. One of the other challenges that we have is service level excellence. We could say we have a certain availability and continuity guarantee that we need to give to the hospital. We can't really, in comparison to workloads that you run on HPC, we can't really say to the physicians, sorry, the HPC cluster is going down for maintenance for a week, tell your patients to come back next week. So that's not really an option. So that's an important one that we have to keep in mind, since a lot of these workloads are usually done on HPCs, which are not really useful for that sort of workload. So now I'm going to hand it over to Abhi, and he's going to talk a bit about the ones that are more specific for his use case.
Thank you. So in terms of, well, beyond the challenges we have already talked about, there are a few more challenges which are sort of a recurring theme when you think about genomic surveillance in Global South. So first of all, disease burden, and particularly when I say disease burden, I mean tropical infectious diseases. And when we talk about Global South, most of the countries in Global South are low and middle income countries, which means there are obvious budget constraints and the financial investment which can go into healthcare systems and healthcare facilities. This leads to a knowledge gap between all the cool advancements which are being done in the field of biomedical research and how quickly they get integrated and implemented within the healthcare facilities. And lastly, there are edge locations. So edge locations are basically any location which is outside metropolitan areas, because we might not have enough computational infrastructure or networking infrastructure, or sometimes even consistent power supply in these locations. So these challenges, they basically set up, they dictate the challenges that we want to address, they dictate the design principles that we can rely upon to build the solutions. And then, yeah, handing it over to...
So now I'm going to talk a little bit more about the why of our project, so how we ended up in a situation where we had the need to develop the nf-nomad plugin. So originally, like I said, we had a few hardware or organizational challenges that kind of limited the options we had to run our workloads. This was way before the existence of Nextflow. So it was not as bad as with nanopore people. We're not stuck in the basement, but we also got started with like 2 or 3 servers literally under a desk. So we got started there. We quickly outgrew that, so we needed something to build, something bigger, like a cluster. So naturally, we decided to over-engineer our cluster and deploy a completely on-prem OpenStack cluster, which worked really great. We were really happy with it, surprisingly easy to manage. We were quite happy with it for a while. But once we ended up using more workflow scheduling workloads like Nextflow, it didn't really fit the use case for OpenStack too much. We didn't want the overhead of virtualization. We wanted to make it a little bit more easy to use container workloads without having the virtualization overhead. And since our cluster hadn't been upgraded in I think 8 years by that time, we also wanted something that was a little bit easier to manage and update with the release of new technology. So that way we kind of ended up where we are at now. So we developed a HashiCorp Nomad-based cluster, which for us makes it quite easy to handle most of the workloads that we have. So besides Nextflow, we have a lot of continuously running services. These are very essential in the work we do. Nextflow is only part of our workload. We analyze a lot of data. We need to present this data to our users. So we need a user interface. We need databases to keep the process data. We need to run services for other users in the lab. So we need a lot of long-running services. And instead of putting them on separate servers and kind of dividing our resource pool, we decided to use the Nomad system, which makes it very easy to mix continuously running services and batch workloads. Unfortunately, we wanted to keep using Nextflow. Well, not unfortunately, but there was no alternative to really run that natively on Nomad. So we ended up in this bit of an unwieldy solution where we run Slurm cluster in a container on Nomad, which was not really a good solution. So I don't know how we actually ended up meeting with Abby, but we got to thinking probably somewhere in a Git issue post where we were pushing the HashiCorp people or the Nextflow people to develop an executor for Nomad. And we started to build it ourselves. So that's how we ended up in a situation now, which gives us a lot of flexibility to run everything together on the same hardware. So Abby, tell me more about your use case.
Okay, so on the other hand, other side of the spectrum, we have precision public health, where the focus is not so much on the individuals, but rather on understanding and identifying transmission chains and clusters and outbreaks. So these are the 3 consortiums that I'm participating in. All of them are based in Global South. And the first one is ReviJet, which aims to really build capacity of genomic surveillance for tuberculosis in north and northeast of Brazil. The next consortium is Gemibra, also based in Brazil, but this time the focus is at a national level and really going beyond tuberculosis to all mycobacteriosis. And then finally, there is GenPath Africa, which is a multinational consortium in which many African nations are participating. The idea is to have genomic surveillance for classical as well as new and emerging pathogens in Africa. So while working with different researchers in these consortiums, I ended up noticing a few recurring themes that we have already mentioned in operational challenges. And HashiCorp's Nomad kind of lands into a sweet spot because it makes it easier to bootstrap the surveillance programs. And then at the same time, it makes it, the operational simplicity of maintenance makes it easier to keep it running in the long run. So that's how we ended up with the nf-nomad plugin. What it does, nf-nomad plugin is simply allowing Nextflow to talk to Nomad and submit jobs to the Nomad cluster. The objectives that we set out for ourselves right from the very beginning were that the solution that we come up with should be free and open. It should accommodate existing infrastructure rather than rather than adding on more pressure to the budget constraints and requesting or requiring people to make investments, upfront investment in new infrastructure. And then finally, we wanted the solution to be elastic. It means that if there is an ongoing outbreak, people should be able to add new nodes and then run their workloads and then remove those nodes as and when they need to downgrade or downsize. Then the Nomad plugin, nf-nomad plugin, is currently usable, and it is on version 0.3.1. And we regularly run a few workloads on 3 clusters. So the first cluster is at University Hospital Ghent under Tom's leadership. The second cluster is hosted at Stellenbosch University, where we end up doing lots of experiments in terms of what kind of infrastructure or infrastructural pieces can be put together. What is the minimal set which can be used which is needed so that people can run Nextflow pipelines on a routine basis. And we end up using a lot of services like Fusion file system as well as Wave Container Service. And finally, we have another cluster on Azure, specifically NF-Core's Azure infrastructure, which is the workhorse for routine development and routine releases for the plugin itself. Then the kinds of workloads that we are using right now, they basically represent our own use cases. The top 3 are from Tom's team, and the last few are from basically the surveillance work. Before we move on to the next steps, I have to say that this has been a very pleasant journey, and I would like to thank Phil and NF-Core team, Paulo for their support from day one, and of course, Jorge for his contributions all across the project. So thank you.
We're not done yet, sorry. Just want to go over some next steps very quickly. So the next few features, when you want to go towards more of a stable release, is to work a little bit more on hybrid infrastructure to make it a little bit easier to scale it over different clusters by managing it to the same plugin. Automations for routine analysis, by which we mean to make the deployment as cheap as possible, preferably like almost a push-button deployment. We also want to focus a bit more on actually optimizing the workflows for our plugin. And we just want to mention that we have a lot of architectural meetings and talks during the development, so you're always welcome to participate and talk to us on Slack if you want to get involved in developing the plugin. So here, just it's not us just working on this. So there's a few other people. We already mentioned Jorge, Matthias and Jules on my team, and then we also Abhi's promoter, and you see the logos of our institutions. And I just noticed that I forgot my own employer. So I'm sorry. Please pay me at the end of the month.
Yeah, and on my side, I would just like to thank my own support system, which is the reason I don't end up breaking in production. So Emmeline, who is my collaborator in all of these consortiums and also my life partner, she is the biologist between us, and they can be a lovely but potent source of interesting problems. You have been warned. And then, of course, I want to thank Professor Tromp and Professor Gyan van der Spee for really just exploring these rabbit holes we end up discussing and going through. Last but not the least, I would like to thank SMRC and, of course, Nextflow Ambassador Program for making it possible for me to be here. Thank you so much. Now we are done.